Good morning, everyone. Today we are going to discuss about regression. What is regression and what are the types of regression and how we predict the value in regression. We are going to learn today's class. So here we predict the regression value. Regression value is the output value. We are taking the whatever given prediction values that are based. We are find out regression value. So regression modeling is a process of determining a relationship between two or more independent variables and one dependent variable. That is known as regression. For example, we want to predict a value of a height of person. So how we predict? So based on independent variables. Based on independent variable, they are given the age of the person. So we are predict now height of the person. So how we predict the height of a person? So predict the height of a person value is dependent on age of the person. So independent variable here is age of the person. Now we are going to predict the value that is the dependent variable, that is the output, that is height of a person. So here is the example. Predict the height of a person is given the age of a person. Another example of regression is predicting the price of car. Given car model, manufacturing, year of manufacturing, mileage, engine capacity, etc. So here two more one and here in first example only we are taken one independent variable, but here in second example we are taken so many independent variables. You see, car model given, manufacturing given, year of manufacturing given, mileage given, engine capacity also given. But here we are have to predict the value of price of the car. So this is the best example of a regression. Now we are going to discuss about types of regression. Based on the types of function used to represent the relationship between the dependent and the independent variables, the regression models are categorized into four types. First one is a simple linear regression. Second one, multiple regression, polynomial regression, logistic regression. So we have four types of regressions. We will see now one by one. First one is simple linear regression. Simple linear regression. How we calculate simple linear regression means here assume that there is only one independent variable x and one dependent variable y. So we are find out these two between relationship. So we are calculating y is equal to a plus bx. Here y is the output value, means dependent variable, and x is independent variable. Second type regression is multiple regression. Multiple regression assumes that there are multiple independent variables and only one dependent variable, that is output variable. Here independent variables are x1, x0, x1, x2, x3, so on. Here is the relationship between independent variables and dependent variable. Multiple independent variables and one dependent variable. That is known as multiple regression. Here is the formula of y is equal to a to the base of 0 plus a to the base of 1 x1 plus a to the base of 2 x2 a3 x3 and so on. So then we find out only one independent variable by using the multiple independent variables. That is known as multiple regression. Third regression is a polynomial regression. Here the value assumes that there is only one independent variable x if the relationship between independent variables x and dependent variable y. Modeling by the relation is known as polynomial regression. For example, y is equal to a base 0 plus a1 x to the power of 1 plus a base 0, a base 2 x square plus a base 3 x cube, like that. So on, we are predicting the value of y. So here we are taking only one dependent variable and polynomial independent variables. This is known as polynomial regression. Here we are predicting the value of y, that is a dependent variable, based on independent variables of x, that is known as polynomial regression. Logistic regression. Logistic regression is used to predict the dependent variable of binary, means 0 or 1, true or false, yes or no in nature. That is known as logistic regression. Like that, we are find out the regression value in four types. First one is simple linear regression, second multiple regression, third polynomial regression, fourth logistic regression. Okay, let me see about uses of regression analysis. A regression can help financial investment professionals as well as professionals in other businesses. Regression can also help predict sales for a company based on weather, previous scales, GDP growth, or other types of conditions. The capital asset pricing model is a often used regression model in finance for pricing assets and discovering cost of capital. Regression is often used to determine how many specific factors such as the price of a commodity, interest rates, particular industries or sector influences, particularly the price movement of an asset. Capital asset pricing model is based on regression and is utilized to protect the expected returns for stocks and to generate cost of capital. Stock returns are regressed against the returns of a border index such as 500 SP to generate a beta for the particular stock. Beta is the stock's risk in relation to the market or index and is reflected as the slope in a capital asset pricing model. The returns for the stock in question would be the dependent variable y, while the independent variable x would be the market risk premium. Additional variables such as the market capitalization of a stock, valuation ratios, and the recent returns can be added to the capital asset pricing model to get better estimates for returns. These additional factors are known as the pharma fringe factors, named after the professors who developed the multiple linear regression model to better explain asset returns. Up to now, we are known very well about useful of regression. Now, let me see about the differences between correlation and regression analysis. Generally, in correlation refers to the relationship between two or more variables, where a change in one is often accompanied by a change in another. In regression refers to the process of returning to the average value, highlighting the average relationship between two or more variables. Second difference is correlation does not necessarily indicates a cause and effect relationship between variables. But in regression analysis identifies cause and effect relationships with the independent variables as causes and dependent variables as effect. Independent variables are causes, dependent variables are effect. In correlation, there exists a mutual dependence between the two variables. It does not matter whether we express it as y is equal to f of x or x is equal to f of y. In regression, it established a functional relationship showing how one variable depends on another. While y is equal to f of x or x is equal to f of y may not both be true, the relationship still exists. The correlation coefficient Rxy measures the direction and strength of the linear relationship between two variables x and y. It is symmetric, meaning Rxy is equal to Ryx, and it does not depend on which variable is considered dependent or independent. In regression analysis determines the relationship between two variables to predict the dependent variable from independent variables. It identifies which variable is dependent and highlights that regression coefficients are not symmetric between x and y. In regression analysis determines the relationship between two variables to predict the dependent variable from independent variables. It identifies which variable is dependent and highlights that regression coefficients are not symmetric between x and y. The correlation coefficient Rxy serves as a relative indicator of the linear relationship between x and y, remaining unaffected by the units of measurement. This value is a pure number that ranges from -1 to +1. Regression coefficients Byx and Bxy indicate the change in variable x of y. By knowing the regression curve's functional form, substituting the dependent variable allow us to determine the independent variable's value in its measurement units. Correlation analysis has restricted uses since it is focused on examining the linear relationship between variables. In regression, analysis examines both the linear and nonlinear relationships between variables, making it applicable in a wide range of scenarios. Okay, students, up to now we are learned regression. What is actual meaning of regression and its examples, and we observed types of regression. In that we observed simple linear regression, multiple regression, polynomial regression, logistic regression. Like that, four regressions we are observed, and in that examples also we are observed, and we are learned more in that. And later we are learned about uses of regression and what are the differences between correlation and regression. So we learned so many things today. Next we are going to observe problems in regression. Thank you.